Welcome to Geometry. This is Mr. O'Shea, and today we're going to be covering lesson 1-6, which talks all about the coordinate plane. So your XY axis coordinate plane. Alright, so on the coordinate plane, you guys are probably familiar with graphs like this. X is that axis and Y is your up and down axis. Points are always plotted with an X and a Y point. So X is your first point, which goes left to right. Y is your second point. We've got 4 different quadrants on it. Now that first quadrant up there is the first quadrant. Then we go counterclockwise to the second, then to the third quadrant, and finally to the fourth quadrant. Points in the first quadrant, those are always going to be positive X's as well as positive Y's. So we went to the right and up, positive, positive. In the second quadrant, it's going to be a negative X to the left and a positive Y because we're going up. The third quadrant is going to be a negative X and a negative Y. And the fourth one is going to be a positive X because we went to the right and a negative Y. Distance formula. The distance between any 2 points, x1, y1, and x2, y2, that just means first point. And the x2, y2 just means, that little 2 there. That means the second point. Oops. Second point. Sorry about that. Now this formula is incredibly important. You guys need to commit this to memory. It's going to be d equals distance equals the square root of x2 minus x1, so the difference of the x values, plus the difference of the y values, and we're going to take both those differences and square them. Okay. Put a big huge star next to this, guys. This will be incredibly important. So find the distance between t, which is 5, 2, and r, which is negative 4, 1 to the nearest tenth. All right, really what we're trying to find here, let's go ahead and plot a general. That could be t, right, over 5 up 2. And r would be left 4 up 1. It looks about like that. So we're finding the distance. We're actually finding the distance between those 2 points. So how long is that piece? All right, so distance equals, we said that was x2 minus x1 and squared plus the difference of the y values squared. We're going to fill in what we know. We got to assign one of them our first point and one of them our second point. So TR, the distance of TR. Let's go ahead and call T our first point and R our second point. So we've got x2, which is negative 4 minus 5. And I got the negative 4 from right here, the second point. Negative 4, x2, right, x2, second point, minus x1, which is minus x1. The 5 is your x1, so I've got negative 4 minus 5 squared. And the y2 is going to be 1, and y1 is going to be 2. Again, x1, y1, x2, y2. So like we said, the 1 came from our y2, and the 2 came from our y1. First point, second point. Alright, negative 4 minus 5 is going to give us negative 9 squared, and 1 minus 2 is negative 1 squared. Do the math on this. This is going to give us negative 9 squared is 81, and negative 1 squared is 1. So now we've got the square root of 82, which is some crazy decimal. So we're going to say TR. We're not going to say equals because we don't really know what it equals. It's a big decimal. So we're going to say approximately 9.1. Now this little symbol, it's kind of a squiggly equals. Looks close to the congruent symbol, but it actually means approximately. So TR is approximately 9.1 on this one. All right, we've got another example here. Find AM. So I want to find out the distance. We've got a little graph here. I want to find the distance between points A and points M. Now, notice there was no line over the top, and that's how I knew it was distance, because anytime we don't have that line, right, we're actually talking about how long something is. So I really want to find out, how big is that? I have no idea. I can kind of take a guess, but it's probably not going to be all that accurate. So we're going to go ahead and use the distance formula, which was x2 minus x1 squared plus y2 minus y1 squared. Now we don't know our x2 and our x1 values here because we're not actually given points. So what we're going to go ahead and do is we got to actually label those points a and m. So am equals all that. Well, a, we'll call that our first point, and m our second point. Now a quick note, you guys, it doesn't matter which one we call our first point or our second point, we just have to stay consistent. So I could have switched those and it would have been perfectly fine as well. Alright, m is going to be over 3 and up 4, so that's 3 comma 4. And a down there is going to be left 3, so negative 3, and down 2, so negative 2. So now I've got x2, y2, because that was our second point. I've got an x1, y1, because we said that was our first point. So we're going to take these values and just plug them into the distance formula right here. Alright, x2 minus x1, that's really going to be 3 minus negative 3 squared plus y2, which is 4 minus y1, negative 2 squared. Calculation now, 3 minus negative 3 is going to give us 6 squared, and 4 minus negative 2 is also going to give us 6 squared. So we're dealing with the square root of 6 squared is 36 plus another 36, which equals the square root of 72. So I know that am equals the square root of 72. It's going to give us another decimal, so we're going to say it's approximately 8.5. So am is approximately 8.5 on this example. Okay, now we're going to go into midpoint. Now hopefully you guys remember midpoint actually splits something into two congruent sections. So the coordinates of midpoint M of AB with endpoints A is x1, y1, and B is x2, y2, just meaning that A is our first point and B is our second point. So we've got some M. It's going to split those up. It's going to basically look like this. We've got A and B. M is the midpoint. So we know that it splits it into two congruent sections. Now A has an x and a y value. We'll call it x1 and y1. B has an x and a y value, which means M also has an x and a y value. And the way that I'm going to write these is x m and y m, meaning x midpoint and y midpoint. Okay, so A was x1, y1. Doesn't really matter. We could have switched that with x2, y2. Either way. But B was a specific value, and midpoint was x mid, y mid. Just some kind of signal connotation we might use. Alright, the formula for it. Again, you need to memorize this one. This is going to be midpoint equals. It's got an x and a y value to it, like we said. But how do we calculate those x and y values? Like this. So the x value is going to be x1 plus x2 divided by 2. It's going to be the average of the x values, and y1 plus y2 divided by 2. So again, the average of the y values. So the midpoint is basically the average of the 2 points. Now let's do an example here. QS has endpoints of 3, 5 and 7, 9. Find the coordinates of the midpoint. Alright, we said midpoint was, let's go ahead and draw this out here. It looks to be about Q. S is over 7 down 9, somewhere down there. We can kind of take a guess then that our midpoint has to be somewhere in this region. We just don't know where it's going to be. Alright, we said that midpoint equals, we'll call Q1 and S2, right? So that means that that's x1, y1. This over here is x2, y2. our midpoint then is going to be x plus x, 3 plus 7 divided by 2, and y plus y, so 5 plus negative 9 divided by 2. Our midpoint then is going to be 10 over 2 because we just did the 3 plus 7, and negative 4 over 2 because we did 5 plus negative 9. 10 over 2 is 5, negative 4 over 2 is negative 2, so the coordinates of our midpoint are over 5, down 2. Looks to be about that point right there. That would be our coordinates for M, our midpoint. Again, all we did to solve this problem was plug Q, x1, y1, and S, x2, y2, into our formula for midpoint, which was x1 plus x2 divided by 2, right here, and y1 plus y2 divided by 2. 3 and 7 gave us 10 divided by 2. 5 and negative 9 gave us negative 4 divided by 2. We simplified. 10 over 2 is 5. Negative 4 over 2 is negative 2. And that's the coordinate of our middle point. Alright, a little bit tougher on this one here. So now we've got a midpoint of AB is M. So now we know the midpoint. And one endpoint is A, which is negative 3, negative 2. Find the coordinates of the other endpoint. So this time around we actually know what the midpoint is and we're finding the other point. So to kind of give us a little visual description of that, that would be like if we knew that M was right here and A was about right here, negative 3, negative 2. We need to find the other endpoint. So this time around we're looking for B. What is it? Alright, we know midpoint is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. That's the formula for it. We're going to plug in what we actually know. And in this case, we do know the midpoint. The midpoint is 3, 4. So we're going to replace M with this. We're going to replace these values with what we also know. Alright, so we know that M is really, like we said, that coordinate. So it's 3, 4. And we also know some of these values. We've got a point. We'll call that x and y, x1, y1, right? Because that is our first point. Now our second point, B, we don't know. So we're going to just leave that as x1. All right, so x1 is really going to be negative 3. But x2, we don't know it, so we're just going to leave it as x, all divided by 2. And our y values, right, our y1, which is from our first endpoint, negative 2, and our y2 comes from our second endpoint, but we don't know it, so we're going to leave it as y, divided by 2. Alright, we're going to do two separate problems here, basically. So the 3 comes from this piece right here. And the 4 comes from this piece right here. So I'm going to solve those out separately. The x value, we're going to go ahead and solve that x value. So we said 3 is really negative 3 plus x divided by 2. And the y value, the y component of that other endpoint, is the 4, which is negative 2 plus y, all over 2. Now we're going to do the calculations here. I'm going to multiply each side by 2 to cancel out the 2 in the denominator. And we're left with 6 equals negative 3 plus x. I'm going to add 3 to both sides, cancel out that negative 3, and we're left with the fact that x equals 9. Now we're going to do the same thing with the y values, solve those. We're going to multiply each side by 2 again to cancel out the 2's in the denominator. And I'm left with 4 times 2 is 8 equals negative 2 plus y. I'm going to add 2 to both sides on this one. And we figure out that y equals 10. Now what that means is that the coordinates of B, our other endpoint, were 9, 10. Alright, so solving it algebraically, we basically had to plug the stuff that we knew into this formula up here and treat it as two separate problems. The 3 came from this piece, and the 4 from the second piece. Now, it might make more sense to you guys to actually kind of think about this in a different way, a little bit more conceptually with it. So let's go back up here to the top and erase a little bit of things here. You guys don't need to erase it on your paper. I just kind of wanted you guys to see another way to think about this problem. All right, think about what midpoint is. It's really stating that you're splitting it, right? So if we know A is -3, -2, and we know M is 3, 4, we can find out the coordinates of the other one. We're going to treat the x values first. So to go from -3 to 3, I went over 6 spaces, which means I have to go over another 6 spaces if M is in fact the midpoint, right? So I went from -3 to 3 is over 6. So from 3 to this next one also has to be over 6, which means that +6 plus 6, that means the b value, the x of the b value is going to be 9. And now let's do the y values kind of the same way, right? From -2 to 4, how many did I go up? Well, I went up 6 spots, which means if that's the midpoint, if M is the midpoint, I have to go up another 6 spots to get to B. So I can go up another 6. Well, we're starting at the 4, this 4 right here, and I got to go up 6 more, which should leave us at 10. Got the same answer. B is still 9, 10. Same thing as we got before, just a little bit more of a conceptual approach to understand that one. You guys can do that conceptual approach, or you can do the formulaic algebra approach, whichever one kind of works for you guys. All right, any questions, please jot them down. Have these ready to go for class tomorrow.